I'm gonna check one more thing just to make sure it looks good. Okay. So I'm gonna let it ride and we're gonna go with it. Okay, that was an adventure. So welcome YouTube, this is Beautiful Mind. I gotta get some new equipment. I would like to have background music and have a whole little production. I have to give shout outs to like Beautiful Mind, Infinite Waters. He kind of like encouraged / inspired me to like, not directly, but to like stream. His journey is like really interesting. I've been following him for at least a decade, I think it feels like. Because I remember when he was streaming in his backyard every day making videos. So I was like, I have to do something to get out there. So this is my attempt to do this. So what this the intent of this session, this is going to be basically some ACT practice. I was doing Uber Eats. You know, I actually enjoy teaching, but you know, it doesn't pay for the lifestyle that I want to live. So as much as I would love to like, you know, let's explore math and see where it goes, I struggle to create the life that I want to live. So I'd rather just live the life that I want to live instead of be poor all the time. Even though I'm still poor, but you know, you still have to go for what you want until you know you can find it. So that's what I'm doing. Um, but that's neither here nor there. But the intent of this session is to you know we basically want to get through as many ACT questions as we can, and so in an effort to not be so long-winded and digress, which I do very easily. Let's see if I can get rid of this. That shouldn't be there. Let's see. Hopefully it'll go away. There we go. Yeah, that's much better. Okay. Um, yeah, so let's do our best to kind of get through these questions. It's a lot. So we have 30 questions that we're trying to get through. Maybe I might go through and do a little bit of editing. I generally don't edit. Oh, also as a disclaimer. So it's 30 questions, so we're going to just kind of take our time and do the best we can. I am a human. I'm a multidimensional being having a human experience. So what that means is I make mistakes, right? So I generally don't look at these in advance. I could make a mistake and I might get stuck on some of them. I haven't, you know, the context, and I'm not really sure of the context. And so we're just going to kind of ride with it and do the best we can. So yeah, okay. So let's start walking through it. First, I like to do like this, okay? And this is the first question, right? So this question says the top surface of a rectangular table has an area of 100 square feet and a width of 5 feet. What is the length in feet of the surface? All right. So with something like this, I would start by drawing a picture, right? So the basic shape is a rectangle, all right? There we go. We got a nice rectangle. Boom. It says the top surface of a rectangular table, so that's why I drew a rectangle. And let's do like this. Maybe there. This one. No. Okay. Has an area. Okay, so let's write that down. So the area of the rectangle. Let's copy, paste. So the area of the rectangle, it says is 100 feet squared, so square feet. All right. It says the width is 5 feet. Okay. The question asks us to find the length. All right. So this is a basic formula for a rectangle. All right. So let's do like this. All right. So we have a rectangle. So the area of a rectangle, I'll try to do my formulas in blue. Area of a rectangle okay. That's just going to be length times width, right? Okay, so let's plug in the information that we're given. We are given, it says the area is 100, so I'm going to put in 100 for A. So, you know, with word problems like this, first thing I would do is draw a picture. All right, so we drew a picture that represents what's going on. Then the second thing is we want to list out or note any information that's given. All right, so that's why we did this part over here. Then we want to identify what is the question asking for? What are we trying to find, right? Then we want to list out any formulas, any relevant formulas, and then we match up with the information given. So they gave us the area. They also gave us the width. The only thing we don't know is the length, right? So the width was 5. So I'm going to put a 5 for my W. And again, L is the only thing we don't know. Okay. Okay. So then we have, so I'm just going to kind of rearrange it. 5L equals 100, right? So if we want to solve for L, we want to use the inverse operation. We have 5 times some number equals 100. So if we want to isolate the L, we want to use the inverse operation. So what's the inverse? What's the inverse of multiplication? The inverse of multiplication is division. So basically we divide both sides by 5. 5 divided by 5 is 1. And then 1 times anything is itself. So then, and 100 divided by 5 is what? 20. So then that result should be 20. Okay. So then if we go back to our multiple choice, I would go with C there. Okay. Let's go on to the next one. Okay. So the next question, okay. So let's use this. Okay, the next question says, a wallet containing 2 $5 bills, 9 $10 bills, and 5 $20 bills is found and returned to its owner. The wallet's owner will reward the finder with 1 bill drawn randomly for the wallet. What is the probability that the bill drawn will be a $20 bill? Okay. So with probability, in general, probability, like for instance, the probability of some event or some outcome is generally, so probability is the likelihood that something's going to occur. And in a simple, overly simple explanation, it's going to be the number of ways for an outcome, or like for something to happen. So we're going to say the number of ways for success divided by the total number of outcomes. Total number of outcomes. All right. Number of ways to success for some event E, right? So this is like an introduction to probability, but it's going to be the number of ways for success for some event divided by the total number of outcomes. That's just what we're going to use here, right? So it says, what is the probability that the bill drawn will be a $20 bill? So how many $20 bills do we have? So we want the probability of getting a 20, or we'll just say, we'll do this. We'll say let E be the event we draw a 20. Let E be the event we draw a $20 bill. Okay. So then the probability of E, how many ways, how many 20s do we have to choose from? It says 2, 9, 5 $20 right here. We have 5 $20 bills, right? So we have 5 20s out of a total of how many bills are we considering? It says 2 $5 bills, 9 $10 bills, and 5 $20 bills, all right? So 2 plus 9 plus 5. So on the bottom, we're going to do 2 plus 9 plus 5. So then that's going to be 5 out of, I didn't mean for that next one to be shown like that. 5 out of, what is that, 16? I'm just going to go with that for now. So hopefully, because like when I did this one, I did kind of look at it in advance a little bit, because at first I was trying to overcomplicate that. I think that's how simple that one is. Okay. Oh, we must be approaching Father's Day. LR Gogeta. They just don't stop. 5 out of 6, and I'm gonna go. What color did I use last time? Okay. 5 out of 6. I will go with this one. And again, I'm not saying that this is 100 correct. I could be making mistakes, but I'm just yeah. I'm just gonna go with it. Okay. So let's go on to the next one. So this one says, in his costume supplies, Elmo the clown has 4 noses, 3 pairs of lips, and 2 wigs. A clown costume consists of 1 nose, 1 pair of lips, and 1 wig. How many different clown costumes can Elmo make? So this is one of those topics in math. This comes out of counting, right? Counting techniques. I'm going to use this technique called it's this bucket or pigeonhole technique. Like, okay, so we're seeing how many different clown costumes can he make, right? And it says a clown costume consists of, we're going to have a slot for the nose, we're going to have a slot for the lips, and a slot for the wigs. All right. How many different clown costumes can he make? Let me think about it. Okay, so say he's building a costume, right? So first he chooses a nose. How many noses does he have to choose from? Well, he has what? 4 noses. So he has 4 choices there. So he can choose either nose A, nose B, nose C, or nose D, right? Suppose he chooses nose A. So now he has nose A. How many choices does he have for the next step, right? So how many lips? So he can do lip A or lip B or lip C, right? So for the first choice, he has 3. He has 3 of the next. So say he chooses nose A and he chooses lips A. After he chooses lips A, how many choices does he have next? So then after he chooses lips A, he has 2 choices there, right? What we're experiencing, for each choice that we have in the first slot, we have 3 choices of the next slot. But then for each of those, we have 2 in the next, right? So I think this is just called, what we do here to get the final number is we just multiply these numbers, right? That's called like the multiplication principle. That's in like probability and counting. 6 times 4 is 24 costumes. All right, and we can list them out. You can do like nose A, lip A. And basically, if you wanted to see this, you could do a tree diagram. A tree diagram, you know, you would do like nose A, nose B, nose C, nose D, and then for that nose A, you would do 3 branches off of that. But this would be too much because you would at the end you would have 24, I think in this case, possible outcomes. And let me just do a quick tree diagram so you can see what I mean by this. So like if you wanted to do a tree diagram, okay. So you know, you would like you could start like here, right? And then you would have what? Let's go nose A, nose B, nose C, and nose D, right? But then for each of those, you have 3 of the next step, right? So then you would have what? Lips A, let's go like this. Lips A, lips B, and lips C. And you can repeat that for each set. Let me go ahead and copy. I'm going to copy. All right, let's put that one here. Paste. And you see how this can grow very fast, right? Because I'm even running out of space doing this. You know, I think you get the gist. I need to do one more if I was trying to get it to fit. Here, let's do like this. Okay, paste. But then for each choice you have in that step, you have 2 in the next, right? And so now at the end of this tree diagram, you'll be able to see all 24 costumes. Okay. So then for each choice, for each step there, you can do what? Wig A or wig B. So you can do like, you need what, 6? You could do wig A or wig B. And let me just, let's do like this. I'm gonna shrink this down and copy. So you need 2, 4, 6, all right? And then we need 4 of those, right? So this is why I didn't start with the tree diagram, because, you know, with small cases you can do this, but then when it gets large, you got to have a sense of, whenever you get that sense of, for each choice you have in the first, every choice you have in the first step, for each of those you have X amount of the next, and then for each of those you have X amount. The simple thing is just multiply, right? I just wanted you to get a sense of the tree diagram. Copy, paste. So there's 1, 2, 3. Oh, we just missed. Okay, there's 4. Okay, we can get it. So this is why I was kind of avoiding the tree diagram, but let's go ahead and finish it out. We've come this far, so let's just finish. All right. Okay. Okay. Let's put you like this, like that. Okay. See now, okay. So now when we go to fill in the tree diagram, basically, like, okay, for instance, the first costume that the person can do, they can choose nose A. Here, let's do like this. And again, this is just for context, this tree diagram. Sometimes this is reasonable. I feel like right now this is probably not the best, but I just wanted you to get this sense. So they can choose nose A, and then lips A, and then, oh, wait. I didn't do this one right. This should be like this. So then they could choose, so kind of run out of space, but that's okay. Wig A, right? So then that first costume would be basically nose A, lips A, wig A. Then you could do nose A, lips A, wig B. You see, and so if you do that all the way down, basically you just trace along the branch. Nose A, lips A, wig A gives you this. Nose A, lips A, wig B gives you this. Then you could do nose A, lips B, wig A will be the next one. And you can basically trace all the branches all the way down. And that would be the tree diagram. That goes, let me see. Let me see if I can make this a little bit cleaner. That could be that or that. That could be that or that, right? 1, 2, 3, 1, 2, 3, 1, 2, 3. This goes here, and you have 2 choices there, 2 choices there, 2 choices there. Like that. And that's just a sense of the tree diagram. Again, it's not always the best option, but it just kind of helps to put things in context, to get some context. Right? So here, let's clean that one up too. Right? So then as you trace the branches, and if you were to list them all out, you would have a total of 24, right? And you can actually count them. This would be the first one, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, and then there's another 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, right? So again, I just did the tree diagram for context, but if you can recognize the counting as for each choice you have in the first, you have that many, you have another amount for the second, but then for each of those, you have something for the next. Long story short, that's just the multiplication principle, and we see it for E. Okay. You know, again, I try to keep it as simple as possible, but I just wanted you to have some context. So if it changes, you know, you can catch the changes. I know this one was overly simple, but you know, we want to do the best we can to kind of be able to catch changes and see even if the question changes, we can still identify it. All right. Okay, that's a little intense, but let's keep it moving. All right, let's go to the next one. So next we have, it says, Esteban and his family are making care packages to send the children at summer camp. Each complete care package contains 5 pens, 2 notebooks, 3 envelopes, 12 cookies, and 5 candy bars. Esteban and his family have already made 7 complete care packages, and the following materials remain. We have this left over, right? 3 boxes of pen, 4 boxes of notebooks, 2 boxes of envelopes, 84 cookies, 4.5 boxes of candy, and it says 10 candy bars per box, 12 envelopes per box, 5 notebooks per box, and 10 pens per box. How many additional complete care packages can Esteban and his family make with the remaining materials? Okay. This one, to me, probably would be easiest with matrices and a little bit of like linear algebra, basic linear algebra, but I'm not going to do that because I can't think of how to explain it simply. So I'm going to just use like brute force, basically just write it out and just to kind of answer the question. Okay, so let's do like this. It says Esteban and his family are making care packages. Okay, so let's see, for a complete, let's do a care package. Let's do this. So a complete care package. Each care package has the following: 12 cookies. So we'll say 12. We'll say C for cookies. Sorry, 5 pens. Let's do 5 pens first. I'm trying to keep the order. So we'll say 5 pens, right? 2 notebooks. 2 notebooks. So I'll say notebooks. 1, 2, 3, 4, 5. 3 envelopes. Let's go like this. Okay, so these are envelopes. 12 cookies and 5 candy bars. Cookies. I'll do K for cookies instead of C. And I'm making relevant variables. I'll do K for cookies. And candy, I'll do D for candy bars. Okay. Okay, so that's a complete care package. It has those items in it. Okay. They've already made 7, and this is what's left over. Okay. So what's left over, it says 3 boxes. Okay. So if they have 3 boxes, let me see, extra. I'll do orange for, let me see, remaining. All right. 3 boxes of pen at 10 pens per box, so that's 30 pens. 30 pens remain. 4 boxes of notebooks and 5 notebooks per box, so that's 20 notebooks remain. 2 boxes of envelopes and 12 per box. So that's 20, 24 envelopes. You see I'm just multiplying. 84 cookies remain. So then 84 cookies. 4.5 boxes of candy bars. If it was 4, that would be 40. So 45 candy bars. Candy bars. Okay, so this is what's remaining. And then it says how many additional care packages can they make? Okay, so let's see. So then I would just kind of like, okay, so let me see if they said one package. One package. Here, let's call it care package. One care package. So if they, in order for them to make the first one, we have to subtract 5. So I'm going to say, I'm going to do like this. Here, let me just move this stuff down to the same page. Okay. Let's actually work in this color. Okay. So now for the first care package, what we're going to do, we're going to, again, we have to, basically I'm just going to keep subtracting until we run out of materials, right? So, let me see. How many could we make? Okay. Okay, let's do this. I'm actually going to change up my technique. The most, if we basically want to find what's the minimum or the lowest, right? If it was based on pins, we could do what, a total of what, 6 more packages. We could do a total of 6 more packages if it was based on pins, right? And then we're going to see, okay, we have to take whichever is the smallest. If we did it based on notebooks, we can do what, a total of 10 packages. So I'm going to say or. So if it was based on pins, based on the pins, we can do 6 more packages total. Based on the notebooks, we can do 10. Based on the envelopes, what is that? We can do 8 more packages. Based on the cookies, what is that? That's not 8, 7, 70 plus 14. So based on the cookies, we can do 7 more packages. And based on the candy, we can do 9. So then what's the limiting? This is limited to the pins, right? Because with all of these, we could do 6, but we don't have enough to do the 7th package, right? Because again, all the packages have to have the green at the top. And so we don't have enough pins to get to the 7th package. So the smallest number is that we can do a total of 6 packages. So I would just go with 6. Hopefully that made sense. And then they got the numbers we have. 6, 7, 8, 9, 10, 6, 7, 8, 10, 15. That's interesting. Yeah, so we're going to go with 6. That was fun. But yeah, that was essentially like, I think that comes out of linear algebra and like, yeah, stuff like that, matrices. But that was the subject that just killed my spirit. I don't know. It was a lot of nuance, and I felt like I couldn't get any help. So I mean, I guess if I were to pick it up again, I could figure it out. But adulting, right? You gotta feed yourself and be totally distracted in this world full of distractions between chasing money and social media and games and all sorts of stuff, right? My thing is like, okay, if there are so many distractions, why are there so many distractions? Like, it's like, what are they trying to distract us from? To me, I think they're trying to distract us from like going within, because I think if we go within, I think we'll truly unlock ourselves and we'll free ourselves, like through meditation and stuff like that. To me, that's the only logical sense for why there are so many distractions. Like, you have to chase money, you have to work, you have to, you know, it's like we're limited by either fear of pain or addiction to pleasure. We work because we want to be protected and we want to either be secure or be free, right? Either we addicted to freedom or we're afraid to starve, right? We don't want to be in pain. We don't want to be uncomfortable. So then to me, it's like, well, what happens when you overcome addiction to pleasure and fear of pain? What's on the other side? And I think where we are, our true selves, I think that's where we are. Anyway, just digressing, my favorite thing to do. Okay. So on to the next one. Let me see. I don't even know how much time, but let me glance at the time really quickly. We have been going for what, like 30 minutes? Okay, that's not bad so far. Okay, on to the next one. So it says a formula for the volume of a right circular cone is this. Okay, so let's write this formula down. Well, let's finish reading. Where r is the radius of the base and h is the height of the cone, using 22/7 as an approximation for the value of pi, which of the following values is closest to the volume in cubic inches of a cone with a height of this and a radius of this? Okay, so they gave us this formula. It says here, let's draw a picture first. The volume for a formula for the volume of a right circular cone. Okay, so basically that shape, a cone. That's fine. So a cone is going to be kind of like this. Nope. Undo. Can we just get an oval? Okay. So something sort of like this. And then here. I'm just being a little meticulous. I'm trying to snap it. There it is. Okay. There we go. And then maybe like this. Okay. Let's do one more. Okay. So then we just want to do something like, all right. Let's see. It says a right circular cone. Okay. So then you have, so the base of the cone is like a circle where the center is like here. And then it's right because, you know, it comes off like this. And the right angle is like here. Nope. Undo. Nope. Come on. All right, so this is kind of like in a 3D sense. And let's go, oh, come on. Let's go style. What am I? Okay. Okay. All right, so this is kind of like in a 3D sense. And the dash lines, let me do one other thing. Actually, this one, partial. And then let's go style. Yeah. Okay. I'm just being a little OCD. Just kind of having some fun. Okay. And then one other thing. Okay. So you have a cone like this, right? Something similar. Style. And this one. Okay. Right? Okay. Oh, and then let's write down this formula. So it says that the volume of the cone is going to be 1/3 pi r squared h, right? So area of a circle is pi r squared. So then the volume is going to be basically 1/3 times the circular base times the height of the cone. Okay. It says r is the radius of the base. Okay, so our r is like here. Do it like this. Basically, R is here. Okay. So it says, and let's add another page. Okay. Radius of the base and h is the height, right? So that's R. H is going to be here. Okay. And then it says, no. Okay. So it also gives us that use 22/7 as an approximate value for pi. So it says let pi be approximately 22/7. They're asking us to find the volume. And it says cubic inches. It says the height is 28 inches. And the radius, 6 inches. Okay. All right, so let's fill in what we have. Okay. I'm going to start by using the formula again, but I'm just going to flip the order. I'm just going to reverse it. So we have 1/3 pi r squared h equals the volume, right? Okay. So then now I'm going to fill in what we were given. So then 1/3, okay. What's pi? It says let pi be 22/7. What's r? R says let be 6, so that's going to be 6 squared. And what's our h? H is 28. So they gave us everything. Only thing we don't know is the volume. Oh, I guess I could have. So I could have left the v on the other side. I was trying to think ahead a little bit, but got a little backwards. So I'm going to put the v back on the left. Okay. So then the volume is going to be equal to that. So then the volume is going to be, okay, let me rewrite it. Let's see. So we have 22 times 6 times 6 times 28. That's not a 28. 28 divided by 3 times 7, right? So when you multiply fractions, keep in mind that these fractions on the right, 36 is the same as 6/1. 28 is the same as 28/1. So when we multiply fractions, it's the top times the top and bottom times the bottom. So we multiply straight across. Don't confuse multiplying straight across with cross multiplying, right? I got to think of a neat way to distinguish that, but this one, to multiply fractions, you multiply straight across. Okay, so then if we simplify, let's see, what can we do? So the 28 divided by 7 turns the 28 into a 4. The 6 divided by 3 turns the 6 into a 2, right? So then the volume ends up being 22 times 6 times 2 times 4. Okay. Let's see. 6 times 2 is 12. 4 times 2 is 8. So 4 is 24. Okay. 6 times 4 is 24. Times 2 is 48. So it's just 22 times 48. Hey Siri, what's 22 times 48? She's playing on the other device. That's okay. Was it 4 times 2 is 8, 20. See, I made a mistake. Yeah. 4 times 2 is 8, times 6 is what, 48? So 48 times 22? 48 times 22. I guess I could just use my calculator. I got one here. I just don't feel like doing that. Where is my calculator? So I need to go ahead and get that going anyway. Okay, let me load this thing because I'm going to need it for some other questions I already know. Choose the file, browse. Oh, I have no idea where this thing is. I think. Let's go back again. Let's go here. Sorry, I'm just trying to pull up my virtual calculator. I haven't used it in a while, and I'm just trying to bring it back. Let's hit done. Come on. It's here. Okay. Then I think it's this one. That looks good. And then reload and refresh. Come on. Okay, let me show you what I pulled up. So this is like a virtual calculator I discovered some years ago. There's some students. This is some students on the site. It says chemtech.net. They made a ROM, and it's been working fairly well as a graphic calculator. So it's virtual. I love it. It works. And I was like, it took me years to find it, and I've been using it for years. So I was like, yeah, just keep using it while I can. Let's just do this. 22 times 6 times 2 times 4. Okay. 1056. Okay. Okay. So 1056. All right. Inches, is it inches? Inches, cubic inches. All right. Undo. Okay. So we got 1056, and you see it there as C. We're going to go with it. Okay. All right. Let's go on to the next one. Let's see. I am starting to get winded. This is why I decided to stream this, because I knew I would kind of be tired. Okay. So we have this triangle ACD below. It says that B is on segment AC. Okay. So we have this segment, and here's B. Okay. E is on segment AD. So we have this segment, here's E. Okay. It says the measure of angle CAD, so this angle here, is 28 degrees, and segment AD, this one, is perpendicular to both BE and CD, so at a 90-degree angle, all right? Okay. What is the measure of angle CBE? CBE, right? Okay. So, this is a straight edge, right? So the measure of a straight edge is going to be 180 degrees. So then if we could find this angle ABE, which is this one here, then we can just subtract it from 180, right? So the interior angles of a triangle should add up to 180 degrees. So this 28 plus 90 plus this angle should add up to 180. We could actually probably use that, but we might get some multiple recursive stuff. But anyway, so then angle ABE is going to be 180 minus 28 minus 90. So let me use my calculator again. So again, those should add up to 180. So if I did 180 minus 28 minus 90, so that angle should be 62 degrees. Okay. So then, so basically it looks like we could have said that 28 plus 90 should be, what is that? 118 or is that 108? 118? So then if we said 180 minus 62, it should be 118. Okay. To get, and I subtracted it from 180 because these are called supplementary angles. Supplementary angles are angles that add up to 180 degrees. So what do we get? 118. So we're gonna go with G. Okay. So again, we basically, once we got to 62, because we got that this angle here, we got that this angle was 62 degrees. So then we said, so this angle over here was equal to 180 minus 62. And that gave us the 118 degrees. Okay. So I'm going to go G there. Okay. On to the next one. What is the sum of this and this for all the x's? Okay. This is a fun one. So then the first one we have the 0.1 x squared plus 3x plus 80. And then we're basically adding two quadratics or polynomials or trinomials. Let's see. So we're going to say plus. And I'm going to line up the like terms. In order for them to be like terms, the variables have to be the same and the exponents have to be the same, right? So we have 0.5 x squared minus 2x plus 60. All right? Okay. So then we just basically add vertically. What is that? 140. 3 plus negative 2 is going to be a 1, so just x. 0.1 plus 0.5 is 0.6 x squared. Okay. It looks like B. I will go with B. Okay. I'm just going to check this stream again really quickly, or as quick as I can. It seems like it's healthy, so I'm gonna just let it be. Okay. All right. That's number 7. Let's keep going. So the next one, it says, students studying motion observed a cart rolling at a constant rate along a straight line. The table below gives the distance the cart was from a reference point at 1 second intervals starting from t equals 0 seconds to 5 seconds. Which of the following equations represents the relationship between d and t? Okay. I was going to draw a picture, but I'm going to just kind of go see if we can. I'm pretty much just going to do a guess and check because it just seems like it would be more simple. So what patterns do we notice, right? So every time we take one step in t, so these are increasing by 1. Are these increasing by 3? If we say plus 3, 15 plus 3 is 18, plus 3 is 21, 24. So it looks like it's increasing by 3, right? Okay, so this seems linear, right? Because every time we take one step on the x-axis or the t-axis, we take 3 steps on the other. That's a linear. We're not like multiplying by anything, right? So we're just adding the same number each time. It sounds linear. So I think we can model this on a linear model, right? And I'm just going to use y equals mx plus b, right? Okay, the b is going to be our y-intercept. So this is our y-intercept, this guy, and this is our slope, right? So the y-intercept, they gave it to us when x is 0, y is 15. So it looks like the y-intercept is 15. So we weren't given the slope. Okay. So it looks like b equals 15. I got that from right here. Because that's when t is 0, then the y or the other variable is at 15. And I'm just going to choose a point. I'm going to choose, let's just choose this first point, when t is 1 and d is 18, right? So let's see. I'm just going to say let t, because I want to solve for the slope, right? And I'm just choosing a route. So let t be 1 and let d be 18, okay? So then if we were to plug it in where it needs to go, we'll get the following. We'll get 18, again, we don't know the slope. Our t, or x, is 1, and our y-intercept is 15. So then we get 18 equals m plus 15. Let's go ahead and solve for m. So if we subtract 15, so then the slope is 3, right? So the rise over run. So then, I know we introduced it as y equals mx plus b, but if we augment it to fit ours, our y is going to be d. The slope we just found to be 3. Our x is actually t. And our y-intercept, which is our b, is 15. So then d equals 3t plus 15. All right? Okay. Hopefully that wasn't too bad. I felt like drawing a picture was just going to be a little bit waste of time, even though we could have 3t plus 15. Let's go with h. Now again, you know, I'm just offering insight. I'm not saying that these are 100% correct. I definitely make mistakes at times. You know, hopefully we are able to minimize our mistakes. Okay. Plus, as the session goes on, my energy, you know, drastically reduces. So then I get foggy, I get tired. You know, then I'm more likely to make mistakes. But let's power through. It says Dimitri bought a pair of pants at the discount price of $30. Okay, the original price of the pants was $40. What was the percent of the discount? Okay. So, okay, let me think about it. So if we have the original price, so we have the cost of the item. Let me see, I'm just making a formula on the spot. What he pays is going to be the original price minus the discount, right? What was the original price? So we want to solve for the original price. He paid $30. We're trying to solve for the original price. Sorry. What was the discount? We're not trying to find the original price. It says the original price was what, 40 minus some discount, right? What was the percent of the discount? So if he paid 100%, he would be at 40, right? So I'm going to rewrite this. So we're going to have 40 equals, sorry. Let me think about it. Okay, so I'm going to rewrite this. So he has the original price of $40 minus I'm just trying to think of how to say it. Because ultimately he's going to pay some discounted price, so we're taking some percentage off. Okay, so 40 minus X percent of 40 equals 30, right? Oh no, not right now. Maybe I should put on do not disturb. Oh no, what are you doing? Oh my goodness, stop. Let's see, how do I turn on do not disturb today? Somewhere here it is, do not disturb. Okay, and let's go back. Okay, so this is what I was trying to process. Here's the original price minus some percent off, or minus some percent of the original price, and then what he paid, right? So we need to find X percent. Now the percent symbol, you can kind of use it as, you can almost do the following. The percent symbol, you can rewrite it as per 100, right? So then what we can do, we'll say 40 minus X times 1 times 1 over 100. Again, the percent symbol, you can pretty much switch those out. And then times 40 equals 30. Again, let's recap that. So we have the original price minus, we have the original price here. Let's do it like this. We have the original price minus some percent of the original price to give us the 30. Okay, I feel like it's a little bit better for right now. Okay, and then the percent symbol, you can just look at it as per 100. Okay. So then, now it's just algebra. So like, say we wanted to clear out that fraction, we could multiply, since it's 100 on the bottom, we can multiply all the terms. Terms are things that we add or subtract, right? So we can multiply each term by 100. So to clear out the fractions, we could say this times 100, we could say this times 100, and this times 100, right? So then if we make those changes, what happens, we get what, a 4 with 1, 2, 3 zeros. This 100 should cancel this. So then we're left with 40x there. And then we're going to say equals. And let me just kind of shift some stuff around to line. I usually like to line up my equal signs. Okay. And then a 3 with 3 zeros. Okay. Now you don't have to do it this way. I'm just offering one route. So then I'm going to add the 40 and subtract the 3,000. So 4,000 minus 3,000 gives me 1,000. If I add the 40x on both sides, I get 40x over here. And then divide both sides by 40. X equals 1,000 divided by 40. So then that's 100 divided by 4. Whenever you have trailing zeros, you can just strike through the trailing, as long as there's no decimals, you can strike through the trailing zeros the way I did. 100 divided by 4 is 25. So 25% off. What was the percent of the discount? Okay, so now let's go back and just ask yourself in the context of the question. Hang on. Let's do it like this here. So in the context of the original question, is this a reasonable answer? Does it make sense? Right? We're always asking ourselves, does it make sense? Ooh, might have to go get something to eat on. So we got 25%. Okay. So then now let's see. If the original price was $40, 50% would be $20 off. So then 25% would be $10 off. All right. So he took 25% off. So $10 off gave him the 30. So 25 makes sense, right? Okay. We'll into the next one. Okay. So here it says, what is the value of this expression? Okay, so I usually like to get a copy. So we have the absolute value of -6. Here, and let's do like paper. Let's get rid of this for now. Absolute value of -6 minus the absolute value of 7 minus 4, right? Oh, 41. Okay, so absolute value, if we're on like the number line, all absolute value is the positive distance away from 0, right? So for instance, the absolute value of 7 is 7. The absolute value of -3 is 3. It's just a positive distance away from 0. That's all the absolute value is, right? Okay, so then the absolute value of -6 is going to be 6 minus 7 minus 41. What is that difference? If that were 10, what is that? 31 plus 3 is 34. So that would be -34, right? But then the absolute value of -34 is just 34. So then that's going to be 6 minus 34, right? And so that minus is there. This minus is this minus right here. I just brought it down, right? Absolute value of -34 is +34, and this one just came down. Okay. So then 6 minus 34, if that were 10, 20, 24 plus 4 is 28, so -28. Okay. And so we got H there. Gotta go get myself some food. All right, let's see. It's 2 o'clock. Okay, let's keep going. That was only question 10. Man, I'm getting old. I don't have like the stamina like I used to. Okay, let's keep going. We got a ways to go. Samantha, Nyla, and Jerry own shares of a stock in the Triumph Hotel Company. The shares of stock that they own have a combined value of this. Samantha owns 70 shares, Nyla owns 50 shares, Jerry owns 40. What's the value of the shares that Samantha owns? One, two, three. Samantha, oh, what's the value? Okay. So we're gonna let what? S be Samantha, N be Nyla, and J be Jerry. Okay, so you have the stock and the value of the stock. So we're gonna let S be the value of Samantha's stock, N be Nyla's value, the value of Nyla's stock, and J be the value of Jerry's stock. Okay. Okay. So 70 shares. So let me see. Samantha owns 70 shares times the value of her share plus what? Nyla owns 50 shares times the value of Nyla's shares, and let's do capital N, plus Jerry owns 40 shares times the value of Jerry's share. So this will give us a total value. The shares of a stock company they own have a combined value of 68.80. 70, 50. Let me think about this. Samantha, Nyla, and Jared own shares in this company. The shares of stocks that they own have a combined value of this. Samantha owns 70. Nyla owns... Oh, and they all have the same... The value of each stock has the same value, right? So even though I'd said the value of Samantha's share and Nyla, but they all... Each stock has the same value, right? So we can use the same variable. We can use the same variable for each of those. So we could say 70x plus 50x plus 40x equals the 6880, right? So now at this stage, we have one equation and we have one unknown we're ready to solve. Every time we have an unknown, we need an equation. So that's why I hesitated initially. I was like, okay, initially I was like, well, we got three unknowns. You know, I was like, we have three unknowns. So I was like, well, do we need three equations? I was like, oh, wait a minute. We don't have three unknowns because the value of each stock is the same. So, you have to kind of shift it around a bit, but, so 70 times the value of each stock here plus 50 times the value of each stock here. So that's why I use the same variable. So then once we have one equation, one unknown, we can solve. Let's see. 70 and 50, what is that? 120 plus 4 gives us 160. So then 160x equals the 6880. So then x is going to be 6880 divided by 160. So I'm just going to put that in my calculator. So it's going to be here. Okay. So my calculator, I'm going to actually do 6880 divided by, I'm using my graphing calculator, so I'm going to do parentheses. I'm going to say 70 plus 50 plus 40. Okay. And then x is going to be 43. So the value of each stock is $43. So then if we want the value of Samantha's shares, so Samantha was this far left, so then we got to say basically 70 times the 48. Yeah, I'm just use a calculator. So then 70 times 48, 70, 50, and that's 90. Yeah, that's about right. She's almost half, right? Yeah, 3360. 3360. Let me see. 6880, 70, 50, and 40. 70, 50, 40. 9, 160. Let me check my calculator. Maybe I didn't type it in correct there. Let me go back. It's probably going to be B, but let me see if I can produce that number. So if I try that again, if I do 6880 divided by 70 plus 50 plus 40, 43. Okay. I don't know where I got 48. Maybe I'm probably tired. 43. So this needs to change. Oops, undo. So that's gone, that's gone. That's supposed to be a 43. Then if I go back to my calculator, so then if I say 70 times 43, it's 3010. So then we're here. Okay. Okay, let's go on to the next one. Give me just a moment. I want to get some water. Whew. Get in some water. Ooh. So yummy. Okay. All right. Let me set this here. Matter of fact, I'm gonna finish it. So a new club wants to attract customers who are at least 18 but less than 30 years of age. One of the number lines below illustrates the range of the ages in years that the customer of the club wants to attract. Which number line is it? Okay. At least 18, so they have to be 18. So the closed circle means you include that number, but less than 30. So we don't want a closed circle because we don't want 30. So it wouldn't be that one. It would be this one, right? At least 18, so they have to be older than 18, but less than 30, but not including 30. All right, it's not these down here because these guys have this stuff over here, so it's not those. It's just, I would just go with G and keep it moving. Okay. In the figure shown below, let's see, E and G. Let me see. It says E and G lie on segment AC. So here's E, here's G, is on this segment. Okay. D and F lie on segment AB. Okay. Segment DE and FG are parallel to BC. So they have the same slope with different y-intercepts, right? And the given lengths are in feet. What is the length of AC? So we're trying to solve for this side over here. Okay. Okay. Now, I'm tempted to use, I instantly go into pre-cal. Dang, I don't know if we have to do it that way. Because you can't necessarily use 1/2 the base times the height or a squared. You can't use a squared b squared equals c squared because you don't know. It doesn't say that, you know, these are 90-degree angles, right? If those are 90s, then we could use like a squared plus b squared equals c squared. I'm tempted to pull out some pre-cal, and I'm not sure if they expect you to know pre-cal for this or not. I'm trying to think if there's another way before I go that route. Oh, we have our related triangles. Okay, I think we can use related triangles. So, because triangle like ADE is similar to triangle AFG, which is similar to ABC. So, for instance, we can use related triangles, right? So we can say 6/12 should be the same as 6 plus 5 over 12 plus x, right? Where x is this distance here. Let me use a different color for x. We'll use blue. X is here, right? So I think we can use related triangles. Okay. So, and then, well, let's do this one first and we'll come back to the next part. And let's do like this, add a page. Okay. So then what is that? 1/2 equals 11 over 12 plus x. So then if we solve for x, now this is a case where we can cross multiply. When we have one fraction equal to another fraction, that's when we can cross multiply. But to multiply fractions, we multiply straight across, top of the top, bottom of the bottom. But in this case, again, we have one fraction equal to another fraction. That's when we can cross multiply. Okay? I know. I hadn't forgotten about you. I need to feed my dog. It's getting late. She was quiet, so I didn't want to disturb her. I might go feed her, but let's go ahead and try to finish this. All right, so if we cross multiply here, on the left we're going to get 12 plus x. Nope. 12 plus x. Daggone it. And on the right, we're going to get what? 22. Subtract 12, and x equals 10, all right? So it looks like this side is 10. So then let's see if we can do something similar, and let's call this y. She's gearing up. No, thank you. No, no, thank you. So now if we do a similar technique, we can still say what? 6 over 12 should be equal to, now let's see this. So now we would do 6 plus 5 plus 4 over 12 plus 10, which is the 10 we just found, plus y. All right, okay. So then on the left we get 1/2, and on the right, on top, what is that? 15. On bottom, 22 plus y. Okay, and again we can cross multiply in this case. So on the left we're going to have 22 plus y, and on the right we're going to have 30. Subtract 22 from both sides, and y equals, what is it, 8? Okay, so we got 8 here. Okay. What is the length of segment AC, so the far right? So then basically 12 plus 10 plus 8, 18, 20, 30, D. So we got D. So that's called similar triangles. When they have the same, when the interior angles are the same, yeah. Just if you look up similar triangles, you know, that's the technique I used here. I can't think of the articulation, but you saw a demo. Let's keep it moving. Okay. Oh, let me get rid of that page. Okay. Which of the following integers is closest to this number? Okay, so square root of 50 is slightly above, okay, so notice, okay, so square root of 50 over 2, well, if we were doing perfect squares, the perfect square below that is what, 49? So on the left, let's consider, I'll say consider the square root of 49 over 2. That's what, 7, and then 8 would be the square root of 64. 64 over 2, right? So this number on the left, square root of 49 is what, 7? So this is what, 7. This is 7 over 2. This one is 8 over 2. Notice, look how close the 49 is to the 50. The 50 is really close to the 49. So it should be really close to 7 over 2. What is that, 3.5? But it's slightly more. So I will go with the 4. No, wait a minute. Nope. Let me think about this. I could put it in my calculator. Square root of 49 is what, 7? 7 over 2 is 3.5. It's slightly to the right of 3.5. So if it's slightly to the right of 3.5, is this right? It's really, really close to 3.5, but it's not close to 3. Yeah. So I think 4. I'm going to go with 4. Because it's slightly to the right of 3.5, so it's going to be closer to 4 than it is to 3. So I will go with 4 there. And we should get a number slightly more than 3.5, which means, it's going to be closer to 4 than 3. Okay. The next one. It says the ratio of Jane's age to her daughter's age is 9 to 2. Okay. So if we did Jane to her daughter, is going to be 9 over 2, right? The sum of their ages is 44. So Jane plus her daughter is going to be 44. How old is Jane? Okay. So this is a case where we have two unknowns and we have two equations. So we have enough information to solve. I think I am going to solve for here, since we want to know how old Jane is, let's solve for J. Let's solve for D in the first one because we want to finish with Jane because we want to finish with Jane's age. So what I'm going to do is solve for D in the first one. So if I consider this first one, are you leaving? All right. Take care. So if we solve for D in the first one, we can cross multiply like this, right? Again, we have a fraction equal to another. So if we cross multiply, we'll get 2J equals 9D. And we said we want to solve for D. So divide both sides by 9. So then the daughter's age is going to be 2/9 of Jane's age, right? Okay. Then we want to take this and plug it into the second equation. So that means J plus 2/9 of J equals 44. Okay. So now at this point we have one equation, one unknown we could solve. I'm a fan of clearing out fractions. Again, to clear out fractions, we can multiply all terms by the least common denominator of the fractions, right? So the only denominator we have is 9. So if we multiply all the terms, again, terms are things that we add or subtract. If we multiply all the terms by 9, then we'll be able to clear out the fractions. So we're going to say this term times 9, this term times 9, and this term times 9. Okay. So then that gives us 9J plus this cancels this. 9J plus 2J equals 53. So then we get 11J equals 53. J equals 53 over 11. Okay. So then, what is that? If that can't be right. Does that make sense? Something's off. Because if that was 55 over 11, Jane's age would be 5, but it's her daughter. Jane's age to her daughter's age. 2J, 90. Yeah, I think that's right. I feel like we're missing something. Let me see. 9 to 2. The sum of their ages is 44. How old is Jane? Mm-hmm. 2/9 of J. Okay. Multiply by 9. Oh, there it is. There it is. I found the mistake. I think I added 9. I found the mistake. Okay. Yeah, I think I'm just getting tired right here. Here's my mistake. I'm going to get rid of this. Okay. 9 times 44. That's where we made our mistake. So let's go. This is why I was using my calculator because I think I just added there. But anyway, clear 9 times 44. 396. That's better. Okay. Because I got an answer and it didn't make sense. 396. That's why I was like, well, let me go back and see. Let me look at it again. Yeah, 396. Okay. So now 9 plus 2. Now we have 11J equals 396. And so then divide both sides by 11 and J equals 36. That's more reasonable. Yeah. Because I was like, how's she going to be 5? I was like, that's not right. 36. Okay. So Jane's age should be 36. "36 is D. And again, I like to do these on the fly just to kind of show like some of the thought process. I know it kind of makes it a little bit more challenging. Man. Oh, let me see how long we've been streaming for. Go ahead and show the next question. Hour and a half, yeah. All right, so let's look at this next one. For the next school year, a college will use 1/9 of the money on its operating budget for library books and 1/6 of the money in its operating budget for scholarships. What fraction of the operating budget remains for other uses? Okay, so let's do this color. 1/9 of the budget is going to be used. Okay, here, let's do it this way. So we have the budget, but then we're going to use 1/9 of it. So 1/9 of the budget for library books. And then we're going to also use 1/6 of the budget for scholarships. So 1 minus 1/9 minus 1/6. So basically what we're doing, yeah, we're just saying 1 minus 1/9 minus 1/6. So the least common denominator between 9 and 6 is what, 18? Because they both divide evenly into 18. So if we get, and we can use a calculator, but if we get all the denominators to be 18, so 1 can be rewritten as 18 over 18. We have the next one, we have to multiply the top and the bottom by 2, so this is the same as 2 over 18. And the next one is 3 over 18. 18 minus 3 is 5, minus another 2 is 13. 13 over 18. We see H here. Okay, 13 over 18. Okay. What value of x makes the proportion below true? Okay, so this is another one where we cross multiply. So on bottom we have this 10 plus x. On top we have 10. Then we have 35 over 42. So again, if we cross multiply like that and like that, again, we have a fraction equal to another fraction. On the left, we're going to have 420. On the right, we're going to have 35 times 10 plus x, right? And what do we need to do with that 35? We need to distribute. So then we get 420, 350 plus 35x. Subtract 350 from both sides. I'm going to reverse the order as well. So then 35x, if that was 100, it would go to 450. We need to subtract, what, 30? So that leaves us at, what, like 70? Oh, I think 70, right? So then 70 divided by 35 is 2. So I'm going to go with A. And again, I mean, you want to check as best you can. Sometimes you don't have the luxury of checking, but whenever possible, you definitely want to check. So like plug it in and make sure that the numbers match up. Okay. On to the next one. It says the rectangle shown in the figure below is partitioned into 3 triangles, 2 of which are shaded. What is the total area in square inches of the 2 shaded regions? Oh, okay. So we have a rectangle, so we know we have 90-degree angles. Let's see. Okay, if it's a rectangle, okay, so I'm going to fill in. If it's a, wait a minute. Oh, okay, so 4 must be that shorter. So then that means that this over here should be 6 inches if it's a rectangle, and then this should be 8 inches. Area of a triangle is 1/2 the base times the height. So area is 1/2 the base times the height. Okay. So for the first one, so the area of the one on the left, it's going to be 1/2. The base is 6, and the height is 8. What is that? 24 inches squared. Okay. The area of the second triangle, 1/2. The base in this case is 4, but the height is still 8. So then that's going to be 16 inches squared. So then 24 plus 16 is 34, 40 square inches. Okay. Okay, yeah, I'm going to go with that. Let's go to the next one. Which of the following ordered pairs in the standard XY coordinate plane satisfies the system of inequalities below? Okay, well, I'm just going to guess and check, right? So if we look at the first one, if x is 1, 1 is not bigger than 2, so we can strike through the first one because x is not bigger than 2, so it can't be that one. It can't be B because 2 is not greater than 2, right? So it can't be that one. C, okay, x3 is greater than 2, 1 is bigger than 0, and 3 plus 1 is less than 5. So that one checks out. Notice 3 plus 2 is not less than 5, so it can't be D. And 0 is not bigger than 0, so it can't be E. So then it should be C there. On to the next one. So the graph of y equals 3, so now that's trig. Y equals 3 minus 5 sine of x minus pi is shown in the standard xy coordinate plane below. What is the range of y? Okay. The range for a graph is generally the very bottom to the very top, right? So this one is like it's talking about transformations. So, you know, you have like the general form for the standard form for like a trig function, and then after like these transformations. So for instance, Trying to think. What is the range? The range is the very bottom to the very top. Okay, let's see if we can track the transformations. Let me think about it. Okay, so I'm gonna build it up like this. So say we start with just a very basic like trig function, right? We're doing sine. So say we just start with like y equals the sine of x, right? So with y equals sine of x, you have like these 5 key points, right? So the general key points for sine, sine starts at the origin. So the first point would be like the origin, 0, 0. I probably should draw a picture for context, but I just don't feel like doing that. I'm just going to track the transformations. But then when it goes, if you go, what, 90 degrees or pi over 2, then the next point is at the top. So that's what, 1, 0? No. So the next point is what, pi over 2, comma, and the height is 1. It goes up to 1. Then it goes to pi, and then to 0. Then it goes to 3 pi over 2, and it's at negative 1. And then finally at 2 pi, it goes back to 0. So it kind of like, it starts like, so say this were like 0, this were the 90, this were 180, this was 270, and this was the 360, right? So then pi sine of x is going to start here. That's where the origin comes in. And then if the height was 1 and this went down to negative 1, the 5 key points you have starts at the origin, then it goes up, then it goes middle, then it goes bottom, then it goes back middle. So those 5 dots is what you see, is what I listed out, right? And so we're going to track the transformations and just build it and then look at the final answer. And so after 2 pi or 360 degrees, we're back at 0, right? So now, let me think about it. Let's look at a change in the amplitude. So like, so now we're going to look at, instead of sine of x, we're going to adjust the outside the amplitude. So we're going to consider y equals 5 sine x, right? So what that does, we multiply the outside of our function by 5. So that's going to, basically, that's like multiplying each y by 5, right? So what we're going to do, we're going to say each y times 5. So we're going to say times 5, times 5, times 5, times 5, and times 5, right? Okay. So then when we do this, we'll have the origin, we'll have pi over 2, comma 5, we'll have pi, comma 0, 3 pi over 2, comma negative 5, and we'll have 2 pi, comma 0, okay? So I just basically multiply all the y variables by 5 there, okay? And basically what I'm doing is trying to build up to this equation here, right? Next, we want to multiply the outside by the negative. I'm just doing it in the order that I think is the most simple. So if we multiply, so that's basically all the y's go from positive to negative, right? So now we're going to say y equals negative 5 sine x, right? So basically we're multiplying each y times negative 1, negative 1, negative 1, negative 1, and negative 1. And like tracking these 5 key numbers to me is the simplest way to do this. Now, there are other ways. I'm just doing a route where once you get it, it works in most cases. So if we multiply each y by negative 1, the origin stays the same for now. We get pi over 2, comma negative 5. We get pi, comma 0. We get 3 pi over 2, comma 5. It flips it top to bottom. Then we get 2 pi and 0, okay? So next, That's going to move it what? Left and right. Let's move up and down first. Okay, so next I'm going to tackle this 3 here. Let me think. Okay, so if we add 3 to the system on the outside, it's going to move, it's basically like adding 3 to all the y's. So let me add a page. Let's add 3 to all the y's. Okay. So in this one, we're going to do +3, +3, +3, +3, and +3. Okay. So now we're going to look at, this is going to be y equals 3 minus 5 sine x. And we're just adding 3 to all the y's. So this gives us 0, 3. And then we get pi over 2, comma, what is that, -2? We get pi, 3. We get 3 pi over 2, 8. And we get 2 pi, 3. Okay. Okay. We're almost there. 3 minus 5. Now we just need to say that, address that minus pi. So now let me think about this. If we're doing minus pi on the inside of our function, that should move it to the right. I think, because the reason I saved the inside for last is it's a little bit, you have to kind of think about it. Let me see. I'm trying to think. That first peak. So if we can just determine if that first peak went to the left or to the right. So it should go up to 3. Is 3? Am I missing something? 5. It moved, oh, the middle, right? So then the first peak, we got what? It's at the bottom now. It's at -2. I see, because it flipped. I think when it flipped upside down, that's what's kind of making it a little bit weird. But I think the first peak is right there. Now we got to decide, did we go right or did we go left? Because normally that first peak, it looked like it went left. So subtract pi. If we subtract pi, let me think about it. Give me just a moment. That original peak was at what, pi over 2, and it's still there. If it was there and we subtract pi, it'd be at what? It would be there. So maybe we add pi. 3 pi over 2? No. Let me think about this for a moment. It's just that last part, the minus pi. Because a lot of times the stuff inside is like the reverse. Let me think about it. Now, that should move. So when we consider this guy here, that minus pi, it should move the original graph to the right pi units. Pi over 2. Let's see. Pi over 2 plus pi is 3 pi over 2. It should be here. I'm just trying to make a decision for that last part. I think I get the impression that we should add pi, because again, a lot of times the inside is the reverse of your intuition. Is really weird. I think we add pi. Let's see what happens if we add pi to all the x's, right? Let's just add pi to all the x's and see what happens. So we're going to say plus pi here, plus pi here, plus pi here, plus pi here, and plus pi here. Now, if we did it properly, all right, let's see what happens. Y equals 3 minus 5 sine x. Sorry. Sine of x minus pi, right? So now if we add pi to all of those, we should have the points. And what we're going to do is basically plot the points. 3 minus 5 sine of x minus pi. Okay. So now, if we add pi, we'll get, the first one is pi comma 3. 1 pi, so that's 3 pi over 2. Negative 2. And I'm just going to plot these points and match it up to the graph. 2 pi. 5 pi over 2 comma 8, and I think that's 3 pi. Here, I'm kind of run out of space. And I'm just going to shrink it down. Okay, so now basically starting with a simple trig function, and accounting for each change, this is how I got it. Okay, so now let's plot these points and see if it matches. So pi over 3, ugh, pencil's getting low. Let's let it charge some. So the first point that we got was pi over 3 comma 3. Right? Okay. So you can see that here. Pi comma 3 is here. Oops. Right. Okay. Pi comma 3, you see it here, so that one matches. 3 pi over 2 comma negative 2. So that's what? 1.5 pi and then negative 2. So 1.5. Now see, that's why I was kind of hesitating. So maybe instead of adding pi, we should probably subtract. I gotta think about this. How did I used to do it? I think it is the reverse. Hang on. I gotta think about that because that might be what's messing us up. Because all we're doing is we didn't have to multiply. We just, what did I do? I added pi. So the first one. Well, let's see what happens if we subtract pi. So then negative pi comma 3. Negative pi and negative pi comma 3 works. Let's go through and subtract pi from each of those and see what happens. Because that one I always kind of have to do that thing. So I'm gonna go back and change all of those pluses to minus. And I'm going to subtract pi from each of those. So let's go back. Okay, so now if we subtract pi, let me just do like this. Because the only thing that's changing there are the x's, so the y's are going to stay the same. Okay, now if we go through and subtract pi, the first one is negative pi. 1 over 2 minus 1 is a negative pi over 2. Then that's 0. And then that's a positive pi over 2. And then that's just pi. Okay, now let's try these and see if this works. And again, it's just when you're working inside the trig function where that gets a little bit like reverse. The inside is usually the reverse of your intuition, but you know, let's try this. Okay. So okay. So now the first point we get is a negative pi comma 3. Negative pi and 3 is there, so that one looks good. Then the next one is negative pi over 2 comma negative 2. Negative pi over 2, dang, we're not getting that one either. Negative pi over 2, and they got a positive 2. Oh, no, that shouldn't do it either. That flips it top to bottom. Amplitude, that probably should have moved it up first, but that shouldn't affect that. It's only the 1x. Let me go back and check my work. Let me back up again. Let me try it again. Okay, let me go back. Okay. So now the key points for sine, you got the origin, 90 and 1, pi and 0, 3 pi over 2 negative 1, and then this, right? So then first we multiply all the y's by 5. We get 0, 5, 0, negative 5, and 0, okay? We probably could have multiplied by negative 5, so then it should be the same, but the signs are flipped. Okay, that's fine. Then we added 3, so just add 3 to all the y's. There's that. Negative 5 plus 3 is negative 2, 3, 8. Yep. And 3. That's 3, okay. So it's just this last one. Let me think about it. Let's see, if we add... Let me try adding pi one more time, because we might have to do like shift it by a phase or a cycle. So I'm going to go back and add pi and see if that fixes it. Because I know that's the only thing that's like kind of getting in our way. Now let me do this again. If I add pi, this will be positive. That's going to be 1 plus a half plus 1 is 3 halves, so that's going to be a 3 pi over 2. What is that? That's going to be 2 pi. Because see, it's going 1 over 2 over 2, 3 over 2, 4 over 2, so this should be 5 over 2. This one should be 5 pi over 2, and then 6 pi over 2, which is 3. Okay. And this is what we did originally. Let me see, let me try that one more time, make sure. So then pi comma 3 is here. That one looks good. 3 pi over 2 comma negative 2. That would be over here. Okay. What am I missing? Well, in either case, since it only asks for the range, I don't know why, because that's the right form, x minus. We don't need to change the form. X minus pi. We should add pi to all of those. Pi. It should be a negative 2. But in either case, the range remains the same. Let's see, pi. I feel like it should be negative 2 and not positive 2. Hang on, I'm gonna plus 3 just moves it up. I'm gonna put this in my calculator just to see if it matches. So give me a moment. Cause I mean the range, we have the range, which is gonna be basically -2 to 8. So it should be H. I'm just trying to figure out like why my numbers are not matching up. And I know I'm gonna go. I'm not gonna spend a lot of time on it because I am getting tired. But I'm gonna graph this really quickly, or try to. Okay, I'm gonna go to y equals. I'm gonna do 3 here. Let me show you what I'm doing. So if I did 3 minus 5 times the sine of x minus pi, I think it needs to be in radians, so I'm just gonna leave it as is. Because if I go to mode, it's already in radians. So now we need the proper window. I'm gonna go to window. I'm gonna do a minimum of, that's what, 6. Let's do negative. We'll do -7 pi over 2. -7 pi over 2. The max is going to be 7 pi over 2, slightly to the right of 2 pi. And we want to go in steps of pi over 2. Okay, so I'm doing 90s. They went in steps of pi, but I'm going in pi over 2. The y minimum, we can go -3.5. The y max, we need to go, let's go up to like 8. We can go up to 9, that's fine. And let's go in steps of 3 like what they did. Okay, I'm gonna hit graph. Yeah, I don't think that graph is right. Something is off. 3, let me go back. That's why, yeah, 3 minus 5 sine of x minus pi. What is the range? The range stays the same, but I think what they graphed is incorrect. I think they forgot to, I think they probably did a plus. Like if I did a plus, I think it'll match theirs. And matter of fact, just to make it more clear, I'm gonna hit enter. I'm gonna go to window. Instead of doing steps of pi over 2, I'm gonna do steps of pi to match them. That's why the hesitation. That's why it's coming, because I think they have the wrong graph. Because when I just put it in the calculator, yeah, they actually have the wrong graph. We found a mistake. So they graphed. They was driving me nuts. I was like, why is this not matching up? They graphed 3 plus 5, but they did not graph 3 minus 5. It says the graph of this, but in either case, the range is the same. But it was like, it was driving me bananas. I'm like, yo, why is this not matching up? It's not matching up because they have the wrong graph. Wow, that's bad. That's not good. Wasting my time. But in either case, the range is the same. It goes from -2 to 8. But they put in a plus instead of a minus. It was driving me nuts. I was like, what? Why am I having such a hard time on this? Because, and it was really like, I could feel it. It was so weird. Anyway, I think they made a mistake. I'm not going to press it. I'm going to let it be. I feel like they graphed 3 plus 5, but then they wanted us to graph 3 minus 5, right? So I'm going to make a note and say, hey, I think this is the wrong graph. I'm going to say this is the wrong graph. That's kind of alarming, though. If like people are spending time and they don't have a professional, and like, and see, that's the kind of stuff. That's wild, because okay, I think this is interesting because like, you know, imagine being a student and you're learning from a text and they have a mistake like that, and you see how I do this day in and day out, and I'm like, wait, why is this not matching up? And so you have to have someone to like say, hey, there's a mistake there. Anyway, it's just interesting because I just recently binge watched like all the Harry Potters, and like in one of the movies, you know, Harry it's the book of the Half-Blood Prince when he's going doing potions, and so everybody's reading their books, and nobody can do the thing right. They were like, why isn't this working? But in Harry's book, he had all these like notes where the person was like, no, don't cut it. You got to crush it with the blade. So he had like corrections where the text was wrong. And so he was the only one that got it right. I feel like this reminded me of that. I think the graph is wrong. But in either case, the answer is the same. The range is the same. It's going to be -2 to 8. And so basically what I did, the smallest y value was -2 and the largest y value was 8 after that process, right? It's still going to work out. And I think we should have done the plus pi. The plus pi should be correct. Well, like what I did originally was correct. I think they just have the wrong graph. Okay. Unless I'm doing something right or I'm missing something, but I think that's the wrong graph. Okay, anyway, let's go on to the next one. Let me get rid of this page. Okay, so that was fun. Let's put this like this. We're gonna go here. Okay. So given this function, f and g, what is the value of, oh, this is fun. This is super easy. Well, I don't know if that's the right terminology, but it's easy for me at this stage. Anyway, so usually when I get stuff like this, I like to, let me start by getting a copy of the original functions. So we have f of x equals 2x plus 1, and we have g of x equals x squared minus 4, right? Okay, and then they ask us to find f of g of -3, right? So this is called a composite function, all right? It's a function within a function. The simple way to do this one in particular, first let's do g of -3, right? So g, we got this x squared minus 4, and we're plugging in the -3. So then -3 times -3 is a +9 minus 4 is 5. Then we're going to take that 5 and plug it into f. So we're going to do f of 5. So then that's going to be 2 times x plus 1, but the x in this case is 5. 5 times 2 is 10, plus 1 is 11. Man, with the subject like pre-cal making a mistake like that, that's not cool. Because pre-cal it takes like focus, and it takes a lot of focus. And to make a mistake like that, and you're not aware that that's a mistake, or have the confidence to say, hey, that's not right, and it's the professional text, that's not right. Anyway, on to the next one. It says a fabric store sells flannel and calico fabrics. Joan pays $25 for 3 yards of flannel and 4 yards of calico. Chris pays $11 for 1 yard of flannel and 2 yards of calico. What's the price? Okay, so this is similar to the 2 unknowns and 2 equations thing, right? So every time you have an unknown, you need an equation. Okay. $25. It says 3 yards of, so 3 times the flannel plus 4 times the calico equals $25. And then 1 yard of flannel plus 2 yards of calico costs $11. And then we want to solve for C, right? So we have 2 unknowns, 2 equations, so we can solve. So for me, it looks like it's easy to solve for, we could add the system of equations, but okay, I think that would be a little bit easier. So I'm going to solve this by a system of equations, all right? You could solve for like f in the second equation and then plug it into the first, but I'm gonna solve the system of equations. So when solving the system of equations with the elimination method, I basically want to get one of the variables to be the same with opposite signs. So to me, the C looks like it's easiest to do. I'm going to multiply the second equation. I don't know what's going on outside. I'm going to multiply the second equation by -2, so that way C will have the same number with opposite signs. So I'm going to multiply each term, basically this whole row, by -2. That's not a 2. Like this, like 2 there, 2 there, and 2 there. So when we account for this, this gives us 3f plus 4c equals 25. We get a -2f minus 4c equals negative 22. Okay. So then if we add these together, this adds up to 0, so that's gone. This adds to 0. 3 plus negative 2 is 1, so that's just f, and that's 3. So f is 3. What is the price of calico? So then we use this to go back and find. So I'm just going to plug it into the second equation. So then 3 plus 2c equals 11. Subtract 3 on both sides. 2c equals 8. Divide both sides by 2. C equals 4. What is the price of 1 yard? $4. That's reasonable. That makes sense. I'm going to go with it. Okay. The scores given below were earned by 10 students on a recent biology test. What is the median score? Okay, so if you want median, the middle score, I think you have to put it in order. And then because we have an even number of scores, we have to take the average of the two in the middle. I think that's how that goes. Because it's not mean, it's not regular average. It's the middle score. What's the middle? But we have we have an even number of scores, so we have to take the average of the two in the middle, right? So I'm gonna do this. We have 71, we have 94, 86, 77, 88, 94, 88, kind of run out of space, 80, 78, and 94, right? So now I'm just going to put these in order. So let's see, 70, 70, I'll just put it here. 94 is about here. 88 is here. There's another 94. There's another 88. Looks like there's a third 94. 78 is about here. Let's move you guys this way. 80 is here, and 86 is here, and then 77. Okay, I just put it in order. Let me do it like this. I'm gonna shrink it down so they fit better. Okay. Okay. So the two in the middle. Okay. So this is what? This is 1, 2, 3, 4. So we need the fifth one and the sixth one. These two. So the average of those would be 87. Notice how 87 is not, that's so tricky. Notice how 87 is not one of the scores. The median score is 87. I'm gonna go 87. Because again, when it's even like that, you take the average of the two in the middle for median. Okay, that was fun. They really be trying to get y'all. It's not right. A parallelogram has a perimeter of 84 inches, and one of the sides measures 16 inches. If it can be determined, what are the lengths in inches of the other three sides? Parallelogram. So a parallelogram is a four-sided figure where the two sides opposite each other are parallel to each other. So it's not necessarily all rectangles are parallelograms, but not all parallelograms are rectangles, right? So the general shape of a parallelogram is something kind of like this. Let me see. Yeah. And again, these sides are parallel to each other. I felt like that was fine the way it was before. Okay. But it's basically something like this, right? Okay. So I'm just going to call like this x. I'm going to call this y. Perimeter. Okay. So perimeter is the distance around the outside. So in this case, we can say like 2x plus 2y should equal 84. It says one of the sides is 16. So I'm just going to say, okay, let y equal 16. So then it should be the case that I think this is safe. 2 times 16. If it can be determined, what are the lengths in inches of the other three sides? Given information. Yeah. Because if this is y here, this should be y as well. This should be x. Because for these to be parallel and for these to be parallel, I think that's okay to do. Yeah. Okay, so then we have one equation, one unknown, so we can solve. So we'll have 2x plus, what is that, 32 equals 84. So then 2x equals 54, so 52. So then x equals 26. So then what? 26, 26, and 16? It looks like H. I'm just going to go with that. I'm going to leave it like that, okay? Man, we are just like, whew, we have been going strong. It's like 2 hours of just talking and thinking. I'm spent. especially with that one that had the wrong graph. Wasting my energy, man. Jeez. I still feel some way about that question that had the wrong graph. Okay. Keep on to the next one. In the figure below, all the small squares are equal in area, and the area of the rectangle ABCD is 1 square unit. Okay. Which of the following expressions represents the area in square units of the shaded region? So it sounds like a ratio. It says all those small squares are equal in area, and the area of the shaded region, oh no, sorry. And the area of rectangle ABCD is 1 square unit. Man, Harry Potter got my mind, like, because now I'm sitting here holding my pen and it feels like a wand. I feel like I'm like casting spells and doing magic. Like in one realm it's called magic and another realm is called science. And it's just like the same thing, just different articulations. Even though I'm a mathematician, I'll be studying like metaphysics and powers and superpowers and stuff like that. It's so interesting. It's so much fun. Anyway, let's go through this one more time. In the figure below, all the small squares are equal in area, and the area of triangle ABCD is 1 square unit. Okay. Which of the following expressions represents the area in square units of the shaded region? Oh, okay. I don't know why I'm overthinking this. So the area. Which of the following expressions represents the area in square units of the shaded region? If that's 1 square, so if 4 by, what is that? 4 by, okay, so I'm just going to list out what we have. 1/5 of it. I'm trying to think how to articulate this. That's why I'm stuttering or hesitating. Let me see. 3 by, we could probably use related. That's 1/6. So if, what is that? 2, 4, this is what? 2, 4, 6, and 2, 4. So 4 by 6 or 4 times 6 equals 1 square unit. We might have to do the area. That equals 1 square unit, right? Three by 5. I feel like we have to do, I don't know if that works. I know it works, you have related triangles. Should be similar. 3 by 5 should be similar to what? 4 by 6? Which of the following expressions represents the area in square units of the shaded region? So 24, okay, let's do this. 24 of the boxes equals 1 square unit. Okay. So 24 boxes equals 1 square unit, right? So then this one is what? 15? So 15 boxes okay. Give me a moment, because this one I'm a little bit, I don't know if I'm tired. I might have to come back to it. I'll give myself a few more minutes. Four by 6. Which of the following expression represents the area in square units of the shaded region? How much of the original? So 15 is x% of the original. Okay. So 15 is, I'm going to do it in terms of percentage, is x% of 24. So then x% equals 15 over 24. I'm not going to do the per 100 thing here. Divide both of these by what, 3? You get 5 by 8. Is there anything that has a 5 by 8? Oh, a 6? Okay. Totally just blanked out. 1, 2, 3, 4, 5, 6. 5, 6. Oh, okay. Oh man. Yeah, I don't know. I think I'm just tired and hungry. I'm gonna get rid of this. So here it is. So area is length times width, right? Okay, finally clicked. Length times width, so 6, right? So we have what? 1, 2, 3, 4, 5. 5, 6. So we have 5, 6 times 3/4. There it is. Because area is length times width. So this length here is 5 by 6, right? From here to here. This other length is what? 3/4. Right? So 5 out of 6 by 3 out of 4. So it looks like this one. I mean, we could reduce it down, but yeah, that's what I think is going on there. Because it's basically length times width. What's the length? Again, the length here, this is 5/6 of a unit. This is 3/4 of a unit. So then that's where I get that from. Okay, I'm going to go with that and on to the next one. A bag contains 16 red marbles, 7 yellow marbles, and 19 green marbles. How many additional red marbles must be added to the 42 marbles already in the bag so that the probability of randomly drawing a red marble is 3 by 5? Okay. 16 red. Okay. So we want, so here, let's do this. The event is going to be, E is going to be, we draw a red marble, right? We want the probability of E to be 3 by 5, right? So we have, okay. So then if we wanted to calculate that, the probability of the event E, would be how many red marbles? So we have 16 red marbles over a total of, we're going to add some additional marbles. We're going to say 16 plus some additional marbles, additional red marbles. Okay. So let me make a note of that. We're going to say that let X be the additional red marbles. Okay. So again, the probability of an event is the number of ways of success of that event over a total number of outcomes. So we're going to take the 16 red marbles that are already there plus some additional amount divided by the total, which is going to be, we got the 16 plus the additional marbles plus 7 plus 19 plus 7 plus 19. Again, we want that to equal 3 by 5. Okay. And let's add a page. Okay. So now that we have one equation, one unknown, now we're ready to solve. I'm going to just get one more. I'm going to rewrite it. So then 16 plus x plus 7 plus 19 under 16 plus x equals 3 by 5. Again, we have one fraction equal to another, so here we can cross multiply like this. So then now what happens is, I'm going to have to shift this over. On the left, we're going to have 5 times 16 plus x equals, on the right, we're going to have 3 times 16 plus x plus 7 plus 19. Okay. Let me line this up really quickly, like that. I generally like for my equal signs to line up. I think I'm just going to forego that on this one because of the nature of it. Okay. So now this one is algebra. We distribute. It's probably better to combine like terms before we distribute on the right hand side. 50 plus what, 30 is 80. 3 times, let me see, 10, 20, 6 and 6 is 12, 13, 13 plus 9, 13, 23, 22, plus another 20 is 42. Hopefully I'm not making any mistakes. X plus 42, okay. So we get 80 plus 5x. Now if we distribute the 3, we get 3x plus 4 times 3 is 126. Okay. Subtract 3x on both sides. On the left, you get 2x. Subtract 80 on both sides. You get, what is that, 46? So then x equals 23. So it looks like we need to add 23 more marbles in order for the probability to work out like that. Okay. 23, and you see it there is G. Okay. Ooh. All right. On to the next one. For all A strictly positive or positive A, which of the following expressions is equal to A to the minus 2? Okay. So A to the minus 2 means 1 over A squared. Yeah, E. Oh, yeah, E. Because a negative exponent moves the thing down to the denominator. So it should just be E. Jamie claims if a triangle is in set A, then it is not isosceles. Later, Jamie discovers that triangle MNP is a counterexample proving this claim false. Which of the following statements must be true about triangle MNP? If triangle is in set A, then it is not isosceles. Okay, here, let me see something. So this is logic. I haven't done logic. I mean, this like it's like set theory. When I took it, it was called set theory, but it's basically logic. We use it for proofs, but it was a whole like modus ponens, modus toner. I mean, I enjoyed it and I was actually really good at it, but I have not seen that in so long. Let me do some things. So here it says if a triangle is in set A, then it is, this is the first thing, it is not isosceles. Okay. Then a counterexample that triangle MNP is a counterexample to prove this claim false. Okay, I'm just gonna say is a counter example. Okay. So in order for it to be, let me see, if a triangle is in set A, then it is not isosceles. So then for it to be a counterexample, we would have to find a triangle in set A that is isosceles. So triangle MNP is a triangle in set A that is isosceles, right? So it has to be isosceles. It is isosceles and in set A? Yep. Okay. Right? Yeah, a counterexample, because again it says if a triangle is in set A, then it is not isosceles. So a counterexample would be, well, I just found a triangle in set A that is isosceles. So then there would be a counterexample, right? So it is isosceles and in set A. I'm going to put a check on that one. It's scaling and in set A. Which of the following must be true? A counterexample would just be to find a triangle in set A that is isosceles. So it is isosceles and not in set A? No. No. I'm just gonna go with the first one. Yeah, I'm gonna just go with F. Cause it's saying, hey, because his original claim was, hey, if you give me a triangle that's in set A, then it's gonna not be isosceles. But then Jamie was like, hey, I found a triangle in set A that is isosceles. What do you got to say about that? But I really think it's F. I think that's the one there. Okay, let's keep going. So I'm about to go. We all got to eat around here. Like I haven't eaten. My dog is like she's asleep. So how to turn into a month? Wow. What? Anyway. Okay, let's keep it going. Okay, so use the following informations for 29 through 32. It says parallelogram ABCD is graphed in the standard coordinate XY plane below. Sides AB so here, and CD are each root 10. So I'm just going to go ahead and label that. This is root 10. This is root 10. Sides AD and BC are 5. So this is 5 and this is 5. The distance between AD and BC is 3. The distance between these segments is 3. Okay, so that's like the drop or this altitude here. Here is 3. Okay. So what is the area? So this first question says, what is the area in square coordinate units of triangle ABCD area? So I think area of a parallelogram is really a rectangle, be base times height. Yeah, I think you can just do the base times that height. So the base is 5 and the height is 3, so I would go with 15. I'm not looking it up. I'm just gonna go with it because basically the basic shape is like a rectangle. Because if you want area, so like say you have a parallelogram. Let me just do this. Redo. Okay, I think that's good. So say I take this guy, right? Okay. So you have the parallelogram. I can do better than that. Hang on. So we're gonna go like this, and then like this, or actually like this, this, and this. Nope, undo. Try it again. One more time. Now technology don't want to behave. I'm trying to get it to. I did it before. There we go. Okay. Okay. And then we had like this guy here, right? That here, let's do it like this. That's fine. And then style. That's fine. And then okay. Then let's go like this. Okay. So now what we could do, so if it's a parallelogram, you can basically take that piece and it goes right here, and then the basic shape is a well, anyway, you get the idea. The basic shape is a rectangle, right? So you can just say it's the length times the width, but in this case, it's the base times the height. That was an adventure. But that's the gist of it. I'm going to just try to put that back. Okay. So 15. Okay. The next one is, what's the distance in coordinate units from B to D? From B to D, so the diagonal. Okay. Let's see. So I'm breaking it down in the basic section. I'm just trying to think. Give me a moment. Let me see. From B to D. Oh, the Ruru. What's the distance in the coordinate units from B to D? We can use the distance formula. Okay, so B is the point 0, 4. D is the point 4, 1, right? We just use the distance formula. They gave us the coordinates, so just use the distance formula. Distance formula between 2 points, distance in this case between B and D, let's see. I usually go x1, y1, x2, y2. So that's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Right, distance formula. So then that should be, so now I went on and labeled them. X2, that's going to be 4 minus 0 squared plus 1 minus 4 squared. Okay. So then that's going to be the square root of 16 plus 9, which is 5. So that one should be H. Okay. What is the slope of BC? Okay, BC, it has a slope of 0, right? Because it's a flat horizontal line, so the slope there should be 0. So then we're going to go A. And even if you didn't see that, you can use the slope formula between 2 points. So let me see, the slope, just rise over run, change in y. So it's going to be y2 minus y1, and let me be consistent. Okay, right here. So the slope formula, again, if you didn't automatically know that thing, y2 minus y1 over x2 minus x1, right? And so this case, BC, 0, 4, and 5, 4. Right, and then you can label it as x1, y1, x2, y2. And then if you plug it in, y2 is going to be 4, y1 is 4, x2 is 5, x1 is 0, 0 over 5. So 0 divided by some number, this is okay. This is okay, right? So this is going to be equal to 0. Some number divided by 0, that's a KO. You want to knock that out. So that's going to be undefined. Right? We can't divide by 0. So we have to ask ourselves, is this a case of OK or is this a case of KO? So we have a 0 on top, so this is an example of OK, so that's why this one is equal to 0. Okay. All right. 31, we're entering the home stretch. Let me see. 33, we're almost there. 2 more. Awesome sauce. I'm so glad I did this because I meant to do this a long time ago. I actually made a video when it was first requested, but I was like rushing. I was actually on my way out and I just forgot. And so the client like resurfaced and I was like, okay, well, let me just go ahead and do this. She just had really good timing as well. Okay. It says parallelogram ABCD will be reflected over the Y. Okay. So that's like, let me think about it. So it's like basically the x's go from positive to negative. So basically, you multiply each x by a -1. What would be the coordinates of the image of A? So if we multiply all the x's by -1, then it's going to be 1, 1, 1, which is J. So that was like transformations from college algebra. When you flip over the y-axis, that's like basically your x's go from positive to negative. If you flip over the x-axis, it's like your y's go from positive to negative, or you just flip the signs of your y's, right? So in this case, since we're flipping over the y-axis, we change the signs of the x's, and so that's how we got the 1, 1. Okay. Last one. Which of the following is equivalent to this? Okay. So we have 8 squared times 4 to the power of 0.5, right? So this is the same as 8 squared times 4 to the power of a half. 0.5 is the same as 4 to the power of a half. Okay. Let's get these to the same base. So 8 is what, 4 squared? No. Let's get them both to a base of 2. 8 is 2 to the power of 3, right? So 2 to the power of 3 squared times 2 squared to the power of a half, right? So whenever we say a power raised to another power, we multiply. So that's going to be 2 to the power of 6 times 2 times a half is 1, so times 2. And so then when we multiply exponents of the same base, we add the exponents. So then this is going to be 2 to the power of 6 plus 1, which is going to be 2 to the power of 7. And you see it there for A. So that came out of the rules of exponents. I think that's it. That was an adventure. So I don't know. I think I'm like in another life I was some kind of, or maybe in this life and I just don't know it. I was like some kind of mythical being, because I just enjoy magical stuff and like going on quests and adventures. I found myself watching Onward, where the two brothers, lost their dad. I kind of watched that over and over, and then I actually lost my dad. Like he had a bad heart surgery, so it's just like ugh. So I mean that would happen last year, so that's like a day by day thing. Everybody's processing it their own way. It seems like my two sisters, and now I'm thinking of like Frozen, like Disney, and the parent thing is irritating. It's weird. But I have two sisters, and they seem like they just pour themselves into like work, and I'm just like, meh, I don't care about anything anymore. I mean, I might laugh and play, but on any given day, it's just I'll be kind of going through it. But that's neither here nor there. That's part of life, and as far as I'm concerned, these bodies, these are just vehicles that we use while we're here to navigate this realm. But this isn't who we really are, right? And so when I'm raging and feeling sad like that, that's just because I'm being a baby, and it's like I don't know who he really was. He wasn't his body. That's not him. It was his consciousness, this idea, this being that like went through these efforts to be here and to create this vehicle for me to use, right? So that's I don't know if earlier you heard me say I consider myself a multidimensional being having a human experience, but I think that's what it is. That's just how I feel. So that's neither here nor there. So I say that to say, that was a quest, that was an adventure. That's neither here nor there. But that was fun. So on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.